Here we have a little bit of a strange figure, and we're trying to find x. So in this figure, we know this kind of sloped distance here is 22 centimeters, and we know the distance across this thing is 18 centimeters, and the distance across this part is 8 centimeters. So we're trying to figure out what x should be. Now, you may be wondering, if we have those other measurements, why wouldn't we just measure x? Well, this could be a variety of different reasons. Maybe we no longer have the little piece of thing, we no longer have this in our possession. We just neglected to take that measurement, and we just need to figure it out. That could be one instance. Or maybe it's not made yet. We're trying to design the specifications so that this distance ends up being 22 centimeters, and this one ends up being 18 centimeters. There's all sorts of reasons why we might need to use algebra to do some of these things. So, in this instance, what I'm going to do is I'm going to say, okay, well, if this distance is x, it doesn't have to be strictly in the center. Let's consider that up here. Or it could be down there for that matter. Those would also have to be x. So let me redraw this. That is really sloppy. Let me try that again. This is not much better, is it? Okay. So those distances are both x. But let's see, how does that help us? Well, I know that this total distance from here to here is 18 centimeters. And this distance, by moving those up to the top and the bottom there, I know that this distance here must be 8 centimeters. I'm just kind of following this cylinder, or this part along here. I'm imagining this as spinning this on a lathe, because this kind of looks like it's something you might end up on a lathe with 8 centimeters across, the total diameter there, 18 centimeters diameter there, and this kind of sloped distance being 22 centimeters. You're just trying to figure out how much raw blank you need for this section. That's kind of how I'm seeing this. In any case, if this total distance here is 18 centimeters, well, I don't know what distance this is or what distance that is, but I'm going to go ahead and say that those are the same because, well, this looks like it's symmetric, and especially if I'm spinning this thing on the lathe, whatever happens up top would be the same as what happens on the bottom. So that means that x plus 8 must be equal to 18. This total distance, x plus 8 plus x, must be equal to 18. That's what I've written here. So 2x plus 8 equals 18. Just combining x plus x is 2x. Subtract 8 from both sides, I get 2x equals 10. Divide both sides by 2, I get x must be equal to 5. So that means each of these must be 5 centimeters. And of course, after the fact, after I write that in there, you're like, oh, well, yeah, of course, because it's 10 centimeters total, and we're dividing that by 2. But you'll notice that's exactly what I did over here without having to use any intuition. I just used algebra to do that part for me. So, in any case, we see that both of those are 5 centimeters. So that distance is 5 centimeters. How does this help me? Well, this distance is x, and this distance is 22. So I now have 2 of the 3 sides of a right triangle. This is a right triangle now, because this right here looks like it's measured at a 90-degree angle. It makes sense that it would be, especially if we're talking about machining a part on a lathe, which means that 5 squared plus x squared must be equal to 22. This leg squared plus this leg squared must be equal to that one squared. Alright, so that means 25 plus x squared equals 22 squared. 22 squared is 484. So x squared must be equal to, subtract 25 from that to get 459. And thus x must be the square root of that, which is approximately 2.42, and just, or 21.4, I'll call it. 21.4 centimeters. So in order for this to, this distance here to be 22 centimeters, this distance here would have to be 21.4 centimeters.